This video is on using the conventional gate model 2 within Nexus 2.8. This video has 5 objectives. The first is to provide a background on the conventional gate model. The second is to provide an overview of the conventional gate model 2. Next, we will talk about all the necessary installation requirements. And then I will take you into Nexus, where we will run through a couple of examples. Lastly, we will discuss where you can get CGM2 support resources and where you should go if you should have questions. The conventional gate model, or CGM, is a generic name for a family of biomechanical models which were primarily developed by the Newington Children's Hospital and the Helen Hayes Hospital. This model was first introduced into Vicon products through the Vicon Clinical Manager. Vicon later developed a plugin for Workstation allowing for the utilization and processing of the CGM and rebranded it as Plugin Gait. For the most part, the CGM and Plugin Gait are pretty much the same, except that Plugin Gait allows users to implement different filtering techniques. Since its inception, variants of the CGM have been developed by research groups and then widely accepted by the research community. One such example is the implementation of the knee alignment device, which helped ease the burden of accurate marker placement on the thigh and shank. Conventional Gait Model 2, or CGM2, is a series of biomechanical models which builds upon the work of the conventional gait model. CGM2 was developed by Dr. Fabien Leboeuf at Salford University in the UK with partial funding from Vicon. The model is implemented using Python and thus is also referred to as PyCGM2. In total, Fabien presents 4 models. For more information, please refer to the GitHub page. This site not only contains a detailed description for each model and guidance for marker placement, it also provides references which were used in their development. The following is a brief overview of how each model compares to Plugin Gait. First is the hip joint center model. Plugin Gait uses a hip joint center calculation based on pelvic width and leg length, whereas the hip joint center model for the CGM2 uses a regression equation that is based on leg length alone. Second is the inverse kinematics, or IK model. This technique fits a model by minimizing the weighted mean squared difference between the trajectories of the measured marker and the modeled marker. Simple joint constraints are also imposed to ensure that joints do not detach. In contrast, Plugin Gait uses direct pose estimation for modeling. That is, it uses at least 3 markers per segment to provide pose information for each segment. It is argued that IK is a more true representation of a biomechanical model. Third is the skin clusters model. The original CGM advocated that a thigh and shank wand be used to help define the pose of these segments. Plugin Gait adapted this model by allowing these markers to be directly affixed to the skin. As these landmarks on the thigh and shank can be prone to soft tissue artifact, the third CGM2 model proposes a cluster of markers that will help address or minimize this artifact. Last is the forefoot model. The original CGM modeled the foot as a single segment providing information only on the orientation of its long axis. To help provide more information on the foot, the fourth CGM2 model proposes adding a few markers and creating a second segment, the midfoot. The rear foot will just be the foot orientation as defined within the original CGM. It is worth noting here that all support and validation of these models will be handled by Fabien. Running CGM2 within Nexus requires the installation of 2 main components. First is the preferred Python suite. Just remember that whichever you choose, please make sure to set the path. And the second is the Vicon CGM2 installer. Please note, these installation requirements presuppose that you have Nexus 2.7 or later installed with an active license. To begin, I would recommend that you first download the Vicon CGM2 installer found on the Vicon website. Go to www.vicon.com, click on the menu in the top left and hover over Support and select Downloads. On the new screen, click Nexus. On the right-hand side, you will see Conventional Gait Model 2. Go ahead and click on it. Scroll to the bottom of the page, fill in your email, and accept the terms and conditions. Once you have finished downloading, please unzip the folder. Inside, you will find 2 files, a user guide and an executable. Please open the user guide and follow the instructions to ensure the correct installation of these 2 main components. I will go through these installation steps here.
The most straightforward way to install Python and ensure that your environment is set up correctly is to download Anaconda from www.anaconda.com/download. While you could download your own preferred Python suite, Anaconda is highly recommended if you are a novice user. Doing so also makes it easier to troubleshoot issues in the future. So when you're on the download page, scroll down and select the 32-bit graphical installer under Python 2.7. Click to download. After downloading, go ahead and run the executable. Agree to the terms and conditions, and then I would recommend only installing for yourself so that you do not mess with another user's installation of Python if that applies. As for the installation folder, I would also recommend sticking with the default. When you get to the advanced installation options, please make sure that the Add Anaconda to my path environment variable option is checked. Click Install and wait for the installer to finish. At the end of the installer process, it will ask whether you want to install Microsoft VS Code. Go ahead and skip this. You can always download later if you really want. Once you have Python set up and your environment correctly configured, go ahead and run the Vicon CGM2 installer. Double-click on the executable and then click Yes to begin the installation. This will install all relevant Python packages, model scripts, pipelines, and labeling templates required to run the 4 models described earlier. When finished, it will prompt you to press any key to continue. Do so, and CGM2 is now ready for use within Nexus. Before I begin showing how to process data using PyCGM2, I want to show you the files that are installed and explain how these files are related to each other. First, there are a set of model templates installed. You can look at these by clicking on the Create a New Subject from a Labeling skeleton button over here on the left. The naming convention for each of these models is as follows. The first part, PyCGM2, just lets you know that it is a template associated with the CGM2 project. Then it will let you know whether the template is full body or lower body. Finally, it will identify the corresponding model according to the GitHub page. So for example, PyCGM2-lower limb underscore CGM21 means that it is a lower limb model that should be used if you only want to investigate the effects of the alternative hip joint center calculation. If it ends in CGM1, then it corresponds to the original conventional gait model and should yield results that replicate that of plug-in gait. Next, there are a set of pipelines as seen within the current pipeline list here on the right. Similar to the templates, there is a consistent naming scheme. Again, PyCGM2 informs you that this is a pipeline associated with the CGM2 project. Next, the specific model is referenced. Lastly, calibration refers to a pipeline that should be run on a static trial, whereas fitting corresponds to a pipeline that should be run on your dynamic trials. So for example, PyCGM2 underscore CGM2 underscore 2-calibration corresponds to the pipeline you should run on your static trial if you are only looking to compute the inverse kinematics model. You will notice that the pipelines do not mention full body or lower body. That means the full body and lower body can be run using the same pipelines so long as the CGM2 models line up. If you want to see where your Python scripts are installed, highlight the Run Python operation within the current pipeline. Down below in the bottom right, within the settings, click on the 3 dots and this will show you the folder location. It is also important to note here that, at present, PyCGM2 is only a lower body model. If you want any upper body model outputs, you will still have to run the standard plug-in gait model operations. Now that we understand the naming convention for templates and pipelines, we can put it to practice. In this example, I will run the first PyCGM2 model. That is, the model that uses an alternative equation to calculate the hip joint center. So I've got the static trial loaded and already reconstructed. Over here in the Subjects tab, you can see I have the correct template loaded, that is PyCGM2-lower limb underscore CGM21. You can also see that I have the same anthropometrics input as if I was running plug-in gait. So I'll go ahead and run the auto-initialize pipeline so that it labels my static trial as well as calibrates my labeling skeleton. And then instead of running plug-in gait, I will go ahead and run the corresponding pipeline that matches the template. So that will go ahead and be this one, the PyCGM2-CGM21-calibration. You can then verify that the model is run by checking the model outputs under the subject. As you can see here, the outputs are the exact same as plug-in gait would output. If you want to append an identifier to the end of these model outputs to distinguish them from plug-in gait, you can enter in a script argument. A list of script arguments can be found on the CGM2 GitHub page under the Nexus Apps tab. So if I go ahead and delete these model outputs, I can actually edit in a script argument such as -- check. If I rerun this pipeline now, again, if I come over to the model outputs and look under the angles, you can see that I now have underscore CGM2.1 appended to each of my model outputs. If I want to put in my own custom script, I can go ahead and do that as well. So let me go ahead and delete the model outputs again. Instead of writing -- check this time, I'm going to type in -ps and then equals, and then in quotations, whatever it is that I want to append. So in this case, I'm going to put underscore py for Python. Again, I'll go ahead and run the script. Again, quickly checking the model outputs, I can see that under the angles I have underscore py. If I now run my plug-in gait static as normal, you can see that I get a corresponding set of model outputs that I can compare so that I can look at the differences between plug-in gait and this first model from CGM2.1. I will go ahead and save and then move on to the dynamic trial. So here I have the dynamic trial already loaded. All markers are correctly labeled and any gaps have been filled. I have cropped the trial and identified the gait cycles. I've already gone ahead and chosen the correct pipeline, so in this case it would be pi cgm2-cgm2_1-fitting, and I will go ahead and add in the same script argument as I did earlier. That is so that I can append underscore py to all of my model outputs. So that would be -ps equals, then quotation underscore py, and then another quotation. And then I will go ahead and run this pipeline. Now that this is complete, I will go ahead and process my plug-in gait model as well using the normal pipeline. I don't necessarily want to filter my trajectories or detect any events since I already have them, so I'm just going to go ahead and run this single operation on its own. When that's done, I can come over to my model outputs and I can see that I have two sets of model outputs per variable, and if I wanted to compare, I could go ahead and plot two of these together. So as an example, I could go ahead and select the knee ankle and look at how it is calculated using the first CGM2 model versus how plug-in gait does it. I can then repeat that process for all subsequent dynamic trials. As mentioned earlier in this video, the main resource for these models will be the GitHub page. While support and validation of these models will be handled by Fabian, Vicon continues to work very closely with him to make the models as easy as possible to implement within Nexus 2. As we are made aware of Nexus 2 integration issues, we will document them in the last section of the CGM2 user guide. The model, and thus Nexus CGM2 installer, will be periodically updated to address these issues, so please make sure that you have the most up-to-date version of the installer and that you make yourself aware of this section within the guide.
To make sure you have the most recent version of the CGM2 guide, please go to our documentation page found at docs.vicon.com. Click on Nexus 2. Then in the bottom left you will see additional Nexus reference PDFs. Click on the CGM2 user guide. You can download this guide in the top right.
Thank you for watching this video. As always, if you have any questions about your hardware or software, please do not hesitate to contact us at support@vicon.com.